The problem we are solving for comes from California State University of Los Angeles, ProgFest 2012, Problem 2, Nautical Navigation. The problem states, the Navy of Victorville is looking to change the way it handles navigation. Due to the recent treaties with their neighbor Polar Police, new waterways have opened up that could significantly reduce the time it takes to move from one point to another. For example, to reach Tinytown, Victorville Navy previously had to use Route A followed by Route B. Now they can directly use Route C as seen in the graph. The problem given gives you the coordinates of 1, 1, 1, -3, starting from the origin. As seen in the graph, the coordinate points form a triangle. We need to find 3 things. For the first part, we need to find vector C's positive radian angle. For the second part, we need to find the distance saved by going from the origin to the final destination given by vector C, instead of following the original path, which starts from the origin along vector A followed by vector V, which gives you your final destination. Lastly, we need to find the distance of vector C, which is found within the second part of the problem. For part A, you need to know the trig function of tan theta, which is also opposite over adjacent. By isolating vector C, you can form a right triangle, with the 2 sides given by your coordinate points, in this case 1, -3. Now to find theta, you need to isolate tan. Theta equals tan inverse of opposite over adjacent, opposite being -3 and adjacent being 1. By plugging in tan inverse of -3 into your calculator, the output is -72 degrees. The negative stands for the theta below the x-axis. In order to find your polar angle, which is a positive theta, you add your theta plus 360. So in this case, -72 plus 360, which gives you 288. To convert degrees into radians, you use the angle found, which is 288 times pi over 180, and the output is 5.027, is your positive radian angle. Now looking for part B, which is the distance saved, you need to find the magnitude of each vector by using the distance formula, equal to the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. By plugging in the numbers, vector A equals 1.41, vector B equals 4, vector C equals 3.16. Since you solved for the magnitude of vector C, which is 3.16, this also solves the problem of part C, which asks for the distance of the new path. Now to finish part B of finding the distance saved, compare the original distance, which is vector A plus vector B, to the new distance, which is vector V, converting the formula into vector A plus vector V minus vector C to find the distance saved, therefore outputting 2.25.
Okay, moving on to the implementation. We're going to need to create a couple of functions, and we're going to need CMath and IOStream. For our first function, we're going to create the distance formula. We begin double distance with arguments x1, y1, x2, y2. We create a double value v distance equal to the distance formula as shown, and return v distance. Then we need a function to find the angle. We first define pi, and then we define a double value vector angle equals to arctangent y2 divided by x2 using the CMath library. We then use the x and y values to find which quadrant the vector lies within. If both x and y are positive, no check is needed. If x is negative and y is positive, that means the vector lies within quadrant 2, so you must do 180 plus the angle to find the positive radian angle. If x is less than 0 and y is less than 0, you will get a function that is negative over a negative, which gives you a positive, so no check is needed and the angle remains. If x is positive and y is negative, then that means the vector lies within quadrant 4. So you take the angle and you add 2 pi or 360 to get the positive radian angle. Once the checks are completed, vector angle's value is returned. Next, we're going to need a rounding function. We begin double round with argument double initial. We go on to take the initial value and multiply it by 10,000 equal to an integer new initial to drop the remaining decimals. Then we do double round is equal to the new initial divided by 10,000, allowing for 4 decimals. And then you return round, giving you the rounded decimal. From here, we move on to the main function. We initialize x equal to 0, y equal to 0, and an integer check, which will be used later. Then we initialize doubles x1, y1, x2, y2, whose values will be assigned later. We then ask the user to input their coordinate points, and we assign them respectively. Using the x and y values given, we create 3 values, vector A, vector B, vector C, that contain the magnitude of the respective vectors by using our distance formula function. Next, we create an angle value using our angle function to solve for said angle, and a distance saved value by adding vector A and vector B and subtracting vector C to get said distance saved. At this point, the program has calculated all 3 of our answers that we need. From here, we simply pass each value through our round function to get the correctly rounded values, and we print them out to the user. We also ask the user if a new route is required and direct them to enter 0 if one is needed. We use an if statement to check if the input is 0. If so, we use a goto statement to jump to the beginning of the program, asking for new sets of coordinate points. When solving this problem, there was only 2 main issues that we ran into. Initially, using the sample input and output, we were not getting the corresponding outputs that were given. So we consulted a math professor who confirmed our math to be correct. So we simply disregarded the given output, assuming it was incorrectly given, and solved for the correct output. The second problem is with the rounding function that is used within the program. While it does give us a number that is 4 decimals, the last decimal has a chance of being incorrectly rounded up or down by 1. The reason being is that the function doesn't actually round the number given. It simply returns a truncated number, being a number with the end cut off. So since the last couple decimals are removed, it simply returns the last decimal given without correctly taking into account whether it rounds up or down. The program was simply the correct implementation of the math previously done.